Hello, this is a introduction to Python programming video for classes that I teach using the Murex Python Programming Second Edition book. This is going to cover both chapters 1 and chapter 2. So I'm going to just get right with it and talk about this topic. So the tool that we're going to use for Python programming is called idle, and that comes with the Python download, which I'll show you separately from these slides. So it has a shell and it has the editor and the compiler for Python. So you can open up idle and do everything you need to start with Python programming. So this is a new language for many of you. It's different than C++, C Sharp, C language, just because it doesn't use curly braces and it uses indentation for blocking, and there's a lot of differences in the execution model for how it runs from other languages like C++. So, we'll discuss that sort of thing as well. We'll be doing mostly a console program, of course, but there are other ways that you can implement Python code for a GUI type of application. Um, we'll talk about, the source code, which is for any programming language in a text file that you can edit with as simple as a notepad program within Windows. If you have a Mac or a Linux machine, you could do, the editing with the appropriate editor that's allowed in that environment. Also, VS Code, which is something that I will refer to many times. Visual Studio Code is a very powerful editor, kind of spawned from Microsoft Visual Studio, which is now up to the 2022 Community Edition, which you can use for many other programming languages, but VS Code is kind of more of a lightweight Visual Studio Code. It's less space taking up on the machine and the operating system. Multi-platform, so you can run it in Mac OS or Linux. So very, very powerful editor. It relies on what's called extensions to enable it to run different programming languages besides just be an editor. So we'll see, how that tool works. And then, there's some basics about devices such as memory, disk drives, whether it's SSD, solid state drives, or HDD, hard disk drives. So these are essential things for any operating system. And then, we'll talk a little bit about the difference between systems and application software. Look at, when we get into debugging and testing our programs, different types of errors that can occur, such as syntax and runtime errors, and what an exception is versus an error. So these are, common general purpose programming languages, but there's dozens and dozens of different languages over the years. But these would be what you would see in most college studies for introduction programming courses. You might also see C language or JavaScript or perhaps other, things that are dependent upon, each university or college will have their own approach. So Python is very, very popular these days as a introduction programming language. So you can see that, it's been around for many years, almost 25 years, and it hadn't gained in popularity until, the recent 5 to 10 years. So, but, we'll see how maybe the 2.x versus the 3.x releases work. I'll use the 3.x for most of my demos. So here we see the difference between Java and you can see that Java requires, to create what's called a function, the header, which declares the accessibility private, the storage resource static, and then double is the data type of the return value and the name of the function using camel casing. So you can see that starts with a lowercase but then has uppercase for each of the, if it's a compound word, sort of like a camel's humps. So that's a common way to name variables. So this is not a Java video, but just to compare, we see how we have to do all those declarations. So that's the first two lines within that function: double, monthly investment, etc. And then there's a loop that will calculate the future value of an investment. So as opposed to the Python way of doing it, where we use, in order to declare the function, def, so that's kind of defining the function, we can use the same kind of naming and then the parameter list with three passed values into this function. And then notice one of the bigger differences between the two languages is that there is no need for declaration of a data type. So we see that with the Java, the return value is declared as double at the very top line of that Java program, and then for the Python, there is no declaration of float or double. And then the future value variable is assigned 0.0, but it does not have double before it. So what determines the data type is the thing that is assigned to it, in this case 0.0, which is a float literal value. Notice there's no semicolons either in Python, and then when we do a loop, for example, we have a colon at the end of the loop, and there's something called range. So we're there's different ways to do what's called a for loop. There's other kinds of loops, but notice the indentation from the function def calculate future value is 4 characters, and then so what that means is that everything that is indented 4 or more characters below that header is going to be in control of this function or part of this function, and that's what we call a block of code. Whereas the block of code for the Java program begins with that first curly brace after it says double monthly investment, etc. That basically declaring those variables. That's kind of a continuation of the first line, so that's a very long line taking up that statement, or that taking up 2 physical code lines. But anyway, the open curly brace matches with the closing curly brace at the bottom of that Java program, and that's the block in which the function is defined. And likewise, the loop has the curly braces, so there's no need for specific indentation, whereas with Python you have to have at least 4 characters to indent each block and set, so that it has control over that. So in the for loop, you see future value is indented 4 characters. You can use the tab key if you want, and there's no like closing entity to say that that's the end of the function. It just kind of just hangs out there. So again, no semicolon. So it's definitely different kinds of syntax. Data types are not explicit. They're like Java is, we explicitly declare double whatever, whereas here it's implicit and based upon the assigned value. So that's a unique factor within Python. So Python is a great first language, says syntax that's easier to read and use than most other languages. That's debatable. It depends on what you're already used to, perhaps, but it has the features of traditional programming languages. Sequence, selection, repetition is, your typical foray into, a programming language. In that sequence is just top-down execution of line by line. Selection is an if statement, where you have a different set of code executing based upon some kind of condition that is true or not, and then repetition has to do with looping. So there's many different looping constructs in every language. So you take it language by language. So we can develop all kinds of programs, games, web apps, network, desktop, GUI, console, and many different companies use Python. Of course, that goes without saying. It's just pretty much pervasive across, every company, that there's probably some Python code going on in them, if they have any, amount of code base for running their business, or, as they're developing perhaps to sell software, they might use Python. So it's open source. So open source is a very important feature of programming languages, or, I should say any kind of software where it's worked on by a community of developers and is offered to the public free of charge, under a general license. So, most software you don't own. Even Microsoft software, you may pay for it, but you really have a license to use it. You're not owning it. So open source, you can go to SourceForge to get, a lot of different programs, from games to editors to, different productivity applications. You could find things like Open Office, Apache Open Office, which is kind of like Microsoft Office, but, you don't have to pay for it. So it has all the same components, like a spreadsheet, a word processor, database, presentation software, etc. So, open source is a wonderful thing. Linux is, one of the big things that's open source. And then, it's a lot of things that kind of fall into that genre, or that category of software. So this just shows you how you could run a Python program from the command line, which is kind of a daunting space for many people to work in. If you haven't dealt with that, you may, of course, know how to use File Explorer in Windows, and that's fine. That's common knowledge. And I usually don't cover that in a lot of detail, but in terms of this example here, is just showing how if you go into the command prompt, which is cmd.exe, and then they're just changing into a folder with the cd command, change directory, so that they have access to the file, which is a source file here. .py is the file name extension that we use for Python code, and then you could run it directly from the command prompt. You can do this with Java, with C++, with JavaScript, C#. Any of those languages have a way for you to execute the code from the command line as well. So you should know how to do it both from a IDE, integrated development environment, like Visual Studio or Eclipse for Java, or IDLE for Python, or NetBeans is another Java environment. If you're using Mac OS, you could use Xcode for C++ and other languages. You can use Visual Studio Code, as I mentioned earlier, for many different platforms, which means the operating system and underlying hardware. So if it's a Mac OS on a M3 Mac computer, that would be a platform that's distinct. The M3 being the CPU, it's a RASC based CPU, reduced instruction set computing, versus Intel chip, which is CISC, is the underlying architecture which means complex instruction set computing. So it's RISC versus CISC is really the underlying big difference between the hardware part of those platforms. But then you have the OS, which lies on top of that hardware, uses that instruction set for that CPU. So, they're apples and oranges, so to speak, no pun intended, but, an Apple versus a non-Apple Windows machine, Intel-based. So, going back a few years, Apple was using Intel chips, and then going back a few years from that, they were using non-Intel chips. So they flip-flopped between non-Intel or RISC processors to Intel CISC processors back to, this M2, M3 style processor, which is a RISC processor. So depending upon which platform you're dealing with, you might have a little bit different. Of course, you will have different command prompt, in Linux or in Apple Mac OS has its own, which looks a lot like Linux, and I can explain also how that is kind of an offshoot of Unix, which is the grandfather of Linux, if you will. So the Mac OS is actually more of a Unix-like look and feel, under the hood, so to speak, and at what's called the terminal, and that would be their equivalent to the Windows command prompt. So in a Linux environment, we call it the bash shell, but in Apple, I'm not sure if they have a specific name. They just call it terminal, perhaps. So, that would be the Mac OS shell. So this is a shell of sorts. So it's basically a way to interface with your software, in the operating system, instead of having a GUI shell. So the graphical user interface that we all are used to in Windows, with all the pretty buttons and colors and menus and icons, so that gives us a really great experience as a user. It does take its toll because all of that needs to be rendered, whether with the GPU or the CPU, and takes cycles off the CPU that could be used for other things. But, we accept that trade-off. But if it were on a server, we wouldn't want so much of that GUI to be taking up clock cycles if the server is serving, multiple users for whatever function, like database or web server or email server, etc. So the console really has its place for both, systems administrators, programmers. So, you should not shy away from it. It's something that, you should embrace, and I will use it quite frequently. So this would be a GUI application, so it's running in the graphical user interface. Of course, that's got elements of the GUI, such as labels like monthly investment. It's got a title bar, future value calculator. It's got, buttons to allow you to maximize, minimize, and close out. It's also got text boxes for data entry, and then some additional buttons to manage that application, by calculating or exiting. So that's, very what we call event driven. And, it's definitely different than a console application, which just gives us text output and will, potentially have input too, so the console is actually both an input and an output environments, because the output is to the screen, the input is from the keyboard, but there's really little mouse interaction. There's really no mouse interaction typically, except when you want to swipe something that's displayed and maybe put it on the clipboard, copy it to the clipboard. But so yeah, I mean, they're different environments, so get used to, the two. And then this is a web application equivalent, functionality, but using a browser to render the output, and that's probably, of course, it's HTML and CSS, which is for formatting the HTML, and then some kind of maybe JavaScript to make that functionality happen. So this is another console application which gives you first, the comment at the top just tells you what language this script, if it were to run in a bash shell, that hashbang slash that you see at the very beginning is just, typical for a Linux or Unix environment. It's kind of optional for Windows. So, it's not that critical to have that, but that's just a comment anyway. So regardless of what operating system you're running it from, it's going to ignore that. I mean, it might reference it for a certain purpose within Linux, but here, it's just a non-executable line of code, as any of the hashtag lines would be. So us old timers will call it the pound sign instead of hashtag. But anyway, that you see there's an import statement, so that's something you could do within Python. Similarly, Java has that statement, but it allows you to import a library that you can then use for a certain purpose. So this is to allow you to set the currency formatting to US. So that's, a very specific thing if you're writing an application that deals with money. So then there's print statements that can print a string literal, which you see there in double quotes. You can also use single quotes. So that's one of the deviations from, C++ or C# or Java for that matter, where when you print a string literal, it's got to be in double quotes. But in Python, you could use single quotes in place of double, because it doesn't really have a char type like in Java. You have to, if you're going to use single quotes, it's just a single character that's allowed in that, delimited character, so you can't put more than one. But anyway, so I'll point out the differences whether you already know a curly brace language or not, just so that as you do perhaps learn other languages, you can kind of pick out those differences. And the print statement without anything in the parentheses there is just to generate a new line. And then we have a variable that contains a string with the letter Y in it, and again, they don't differentiate between characters, single character literals, and multi-character literals, which are strings. So everything's a string if it's text, one or more characters. So in terms of the next part, we're getting an assignment statement. So remember, assignment statements operate from right to left in terms of the flow, and instead of like with a calculation statement like that very last line with the years times 12, that's a left to right associativity, as they call it. So the years times 12, for example, gets resolved first, and then the assignment operator occurs, which means that there's got to be a single value that gets resolved to on the right-hand side of the equal sign, that last statement. And then that gets assigned to months, and that's whatever data type happens to be is what months will, take on as its data type. And it could change, which is very strange for those of us that started out with curly brace languages. I mean, I started out with BASIC and Pascal and things like that many years ago, but I even dabbled with COBOL and Fortran and others like RPG and PL1, Programming Language 1. So these are ancient languages. But at any rate, this is a sample program, so it has a number of features that we see. There's a loop at the beginning, and the reason it's saying choice.lower, it's basically so that we don't have to say while choice is equal to uppercase Y and, or rather, or choice is equal to lowercase y. We convert it to lower on the fly, and then we just have to compare it to one of the two so that, we get it in one fell swoop. We don't have to compare both upper and lower, which is the user's response. So, and then we have, kind of an involved statement there. The two, actually three statements that accept values. You look on the innermost is an input statement, which forms a prompt and then generates a tab. That \T is to give us the cursor setting out, to a tab stop. And then whatever value the user types in gets converted to float. So float is the numeric type that we use that has decimal places, like a decimal point, and then some value, one or more point, 8.6 or 8.53, so at any rate, this is also, the second line is identical more or less in that it's going to prompt the user, get a value, convert it to float, and then assign it. So you see how I'm doing the right-hand side first. The right-hand side of that equal sign is what gets resolved and then assigned. And then the third one is years equals int. So in that case, whatever the value is that we type will, as the user will get converted to an int and then get assigned to years. So you see how I'm doing right to left in terms of valuation. Whenever there's a assignment operator, which is the equal sign. So that's a very unique operator compared to other operators like slash, which we see in that second to last line, which is dividing, doing regular division, and then the other one is the multiplication symbol. So there's other kinds of division that we could do within Python, including integer division and modulus division. So this is the rest of the program, and this is, much more advanced than just the introduction that we're doing for this video, but at least you see, kind of the structure and layout. You see some of the patterns that occur in a programming language. You see the indentations, the way that for loops have colons at the end, and I'm going to go back to the previous slide, and the while loop has a colon at the very end. So there's two kinds of looping constructs there. And then it doesn't look like there's any if statements here, but you see, assignment statements, which is basically giving a variable a value. And here they've opted to use underscore instead of camel casing. So that's just a style choice, a preference, that a programmer will make. Underscores add one character, add a character to the variable length. So I really prefer not to use that in favor of camel casing. But so, ultimately this program is going to keep asking the user if they want to continue, yes or no, and that's where if they type, a lowercase y or an uppercase y, it'll be converted to lower before the comparison is made there with the while statement. So this is basically showing us how a Python compiles and runs source code. It's basically, we edit the file in some kind of plain text editor, or, you could fancy it up and have an IDE, as they call it, which embeds an editor within it. But, in any case, you have to take that source code, which is the .py file type, and other languages have their own file type, like Java is .java, C++ is .cpp, C language is .c, C# is .cs, JavaScript is .js, Pascal is .pas, COBOL is .cob. So BASIC is .bas. So you have all these languages that, it was determined that certain file name extensions should be used on the text file. I mean, some operating systems file name extensions are not as prevalent, I should say, in Linux as they are in Windows. Also, Windows is not case sensitive, whereas Linux and iOS, I believe, is also case sensitive. So when you name things in anything other than Windows, you have to be very cognizant of the upper lowercase, because uppercase, if you name it versus lowercase, is going to mean that they're two different files. So we have what's called an interpreter, which this looks a lot like Java. If you ever looked at Java execution, there's actually Java does compile first, then interpret. Here, we could probably see better schematics that tell us more about how Python gets transformed from source code into some kind of executable. But here, they're saying something called bytecode, which is also used in Java as what we call an intermediate language, and that basically runs on a virtual machine, not a virtual operating system, but it's kind of in programming ease. It's basically a execution environment that is portable across any operating system. So this is very basic explanation, but for the most part, Python is an interpreted language, means that there's no resulting executable when you do create a Python program and run it. It just runs from the Python interpreter. So you basically start with the text editor, which can be embedded within an IDE or integrated development environment. Edit the source code, then the programmer saves the source code to the Py extension, and then we compile so there's confusion about compile versus interpret, but we can talk more about the idiosyncrasies of that, comparing it to other languages. But then the bytecode is translated by Python in virtual machines. It almost looks like they're talking about Java here, and then it runs. So you have to, whenever you have a program that's running, has to be loaded into main memory in some way in terms of a binary executable, whether it's done through a virtual machine or a .exe, which is what C++ uses in C language. So those are pure compiler languages. But of course, that file that you're going to load into memory has to be saved first, whether it's compiled or interpreted. It has to be on disk. You can't just put it in an editor and keep it in the editor without saving it. And in fact, if you're using an IDE and you hit run, it automatically saves it because it has to, in order to compile or excuse me, or interpret that file. So here they're just talking about how the OS software loads into main memory. Of course, it has to be running, and then when you start an application, the operating system loads it into memory. So in a sense, you have two copies of it at that very moment where it's on. Like if you're loading up Word, the word processing program, you have it on disk, winword.exe, somewhere on the disk drive. And then when you load it, a copy of that gets put into memory. It's a big program, so maybe not all of it, just the first part, which shows you the interface and the editor, but nonetheless, you have a copy of the program on disk and a copy of that program in memory. The one that's in memory is very volatile and transient, and if you turn off the machine, that goes away along with any data that's managing, such as a document, but the one that's on disk remains. So the application as it runs, the last bullet point there, it says that it may read data from the disk storage also into main memory or RAM or real memory, or there's different ways of referring to that. Way back, old timers that would use mainframes, they would call it core, I think. When I first heard that as a student, I'm like, what do you mean by that, core? But anyway, write data from main memory to disk storage, so you could read or write as needed. So there are, programs that could open files, read them, and then maybe open files and write to them. So that just like Word can open up a document, and then you could edit that document, and then you could save it, so it would be then writing to disk. So this is, IDLE's interactive shell, which you could see they're showing that you could just interactively or immediately type in a statement and get the output. It's not part of a program at all. It's just pretty much on the fly. So you can do treat it like a calculator. You can test out an expression. If you make an error, it'll flag it. You can assign a variable and then print it. So it just gives you kind of an interactive environment similar to the command line, but more specific to Python, manipulating Python elements, statements, expressions. So it's not going to, be able to interpret commands from the Windows CLI command line environment, which we might have called DOS 30 or 40 years ago, but disk operating system. So it's basically not the Windows command line. It's not the Linux command line, which we usually use bash. It's not the Mac OS. It's a command-driven environment, but it's not the same. So it's a shell, but it's a shell that is for Python programmers. So you'll see that word shell used a lot. So to start idle, you just type idle, or you just do it in the search or click on a button. And then the last one, you could run the program. So you can enter the Python code. So let me just demo a little bit about the Python shell. So there's a couple ways that you can launch idle. So the first thing that you do is when you go into your browser, you'd want to go and get the Python download. So this basically is an executable installer. So you can see that you can get it for Windows, Linux, Mac, and let's just see what the other is. AIX, which is a Unix flavor for IBM. iOS, I guess if you want to mess around on your iPhone with that. Z, I think that's the IBM mainframe, ZOS, or Z. Yeah, so that's strange. RISC, Solaris. Okay, so there's that term RISC that I mentioned earlier, but I haven't used RISC OS per se. I don't know where it runs, but Solaris is just a well, I should say it's a Unix flavor that was on Solaris. Rather on a Sun Microsystems operating system from back in the day. Sun stands for Stanford University Network, and it was a Unix that predated, Linux, and then Sun Microsystems was bought up by Oracle. HPUX is the Hewlett-Packard Linux environment. It's Unix, so HPUX is a proprietary Unix environment. So, just showing you that is really telling about different platforms other than the big three, Windows, Linux, Mac OS. So if you're going to do it on anything other than Windows, this video is not addressing that, but I'll do everything I can to actually refer to it and give you a hint as to how to use it there. But I would say look at videos and read articles about Linux and Mac. But if you go to the Windows downloader, I think the default one, which is this button, will basically bring down 3.12, and then if we look at that inside the folder, we'll see, the executable. So then you would just double click on that, run it, and then you'll get Python, so if you type in idle, you'll get the idle shell launching, and then I'm going to just show you something with generating some code using the Microsoft AI. So you can just go in and then say create a Python program to ask the user for 4 items, let's say for mailing list fields, then print it in a label format, something like that. So just a simple little program, and whichever book you may be using for a course, you can find, they're getting a little bit fancy on that with using fields. So they're using a list there. So yeah, I mean, it depends on the prompt that you create, so if I'm not careful, if you don't engineer that prompt properly, you may get the code coming out strange, but so I'm just going to modify that slightly and fix my spelling error. Create a Python program to ask the user for 4 data items in a mailing list. Okay, something like that. Maybe that'll give us something that's a little bit more baseline without those. Now they're doing the same thing. Okay, so we'll just deal with that. So they are, okay. So regardless of what code that generates, whether it's advanced or not, here we could just copy that and then go into the idle shell and then say File, New File, and it brings up a blank text editor which is separate from the shell, and then I could just paste in that code, and then so it's basically using a list of values that it's going to keep track of, and notice that it does have to save it, and you have to give it a name. So what I'll do is I'll show you a little bit of the command line. I'm going to go into the folder, the root folder, like cd / gives me that change from my default, which is users Dan, and I'm going to make a directory called Python programs. Okay, so then when I save this, I could save this to Python programs and give it a name and just call it mailing.py. Okay, so as a result, if I go into that Python programs, I could see that file exists there, mailing.py, but I have it in the idle environment. So okay, so basically it gives me a mailing address, mailing label format, but we're not so concerned about the code itself, but the execution environment. So you see, I just closed out that idle, and then I'm going to focus on doing it here, CLS, if I type Python space mailing, it gives me the same kind of interaction, and if you're just testing something, notice that I'm just putting like 3 digits just as a quick way to, satisfy the program that wants data from me without having to toil over, how do I spell the word, and, because this isn't going to be your final output anyway, it's just going to be, testing it. But using a numeric value is best, because if there is something that is a number that needs to be input, even though zip code is not really supposed to be a numeric value in most cases, because we don't do calculations with it. So I would, just use some number. So the other, so we could make something simpler, like create a Python program to, I don't know, to show a multiplication table asking for rows and columns. So again, you have to know how to prompt it with what your desire is in terms of it generating that. So this is, creating a table as well, and it's insisting on doing that. So if we were to go into a different AI such as Gemini and wrote that same prompt, it may give us a different result. Or if we go into ChatGPT, it may give us, if we want to just start right now, I'm just trying to avoid having to log in. So if I took that same prompt from Copilot, and I'm just trying to avoid using tables. I mean, maybe I could prompt it differently, but it maybe is on that mindset. Let's see how this one generates it. So with ChatGPT, it's just doing a simple, so it's not asking for or putting the data into an array or a table of any sort. So I'm just showing you, okay, that we can copy that code and then use the same workflow, whether we use idle, but we can also use something called Visual Studio Code, which is a tool that is with Microsoft. So I'm not going to save that. And then it's just basically something I had in there from a previous talk, but you would just basically say file, new text file, and then paste that in, and then you have to save it. So I'm going to save it to my Python programs folder and call it multtable.py. Okay, if it would let me. And then, so notice that this environment, it's got a different color scheme, black background instead of white background, and then it colorizes the text once it knows the the programming language or file type that is. And you have to set up this environment to run Python by having the appropriate extension. So this button over here tells you, what extensions you currently have, and I do have C++, and I do have Python and things like that. So in fact, if you do run this or try to run it, you could just say run, and then run without debugging is usually how I start it. And then you select this Python debugger, and you'll see on the bottom it gives us a terminal. It's actually a PowerShell terminal, which is the other shell that you can use within Windows besides the Windows command line. It's PS, so it's a much more rich, capability environment. But if I said a 5 by 3 output, it does give me the output readily, and I'm not using idle at all. I just have Python installed, and then I put the extensions in there. So the other way to run that same program is just to type Python space mult table, and then 5 by 3, I get the output. Or the other way is to open up idle, which, okay, I don't have it in my path, but we can open up idle from here, and then we could just open up a file that exists already, and it's in a folder called Python code, or Python programs, right here, and then I could select this, and then I get that in this editor. So this is a different, of course, different editor than code, VS Code, and then we could readily just run it, and then we'll get an output window there, 10 by 12, whatever, and we get that. So that, regardless of what the code is, this was generated with ChatGPT. To execute it, we have to know the different tools to use. And just to, kind of briefly walk through this, this is the entry point. It's going to, call this main function, and then ask the user for 2 values, rows and columns, similar to what we saw in the slide. Here's using an if statement and saying that you should not put 0. So it's validating the input, and then finally it's saying, well, once I've gotten valid numbers, then call this function and go through this looping to make a heading line, and then do what's called a nested loop. So again, that is way, way beyond what we're talking about. So I just want to show you those different options, and then finish up these slides. I think I'm going to make this in 2 videos, this chapter 1 and then chapter 2. So the interactive shell, I think you could get into that. So if we go to my Python, and you could type CD and then type part of the line, the folder that you want to go into, and hit the tab key, and it will cycle through until it finds the one that you want. And then, so I'm going to clear the screen, and if I type in Python, okay, it gives me, I could say, 8 times 8 and get a value. I could say print hello world. So that it gives me a shell, even though it's not invoked with idle, it's just the shell. And I could say, x equals 3, and then print x. So I think you just type x, and it'll output the value of that. So in a sense, you can get a shell with these 3 greater than symbols indicating that that's a prompt, and execute different things. We could say if x is equal to 2, then print, we could maybe indent, print 2, else print not 2, and then so x is equal to 3. So even though this code is not even part of a program, I could actually, test out an idea that I have about coding an if statement without, putting it into an actual source file. But, that's kind of a waste of writing code, because I guess you can copy and paste it later. But so the point is, whether you use this, you could get out of it by typing exit, and then exit takes you out of the shell, the Windows shell. You can always reopen the shell very readily just by typing cmd. It gets you into a shell, and of course it defaults to a particular folder. So, just to finish up this, you could, there's a lot of commands that you could execute within that prompt, but if you enter an invalid code, the shell displays an error message, of course, and then idle this is just showing us the idle editor with source file displayed, and then obviously, whatever that code is, you can run it. And then, this is just pointing out how idle, you can use the file menu to open things. You can switch between source and shell. There's a window menu. And then you could edit the file within the editor, so typically you have two windows. You have the editor window and the shell that's idle, and then how to compile and run it. You can hit the F5 key, or just go to the run menu. Idle displays a dialog box that indicates you must save the program. So that's basically, like I said earlier, if the file's not saved, it can't compile it. So make sure you give it a valid name .py. And then, here we have a syntax error where, I don't know, whatever that error is, misplaced quote, not sure what that error is. Anyway, it could be from a previous line if you have an error in a previous line, but I really don't see the error on that years equal. So you may see it. Okay, but a message that's displayed for the runtime, so that would be a syntax error. I think it's missing a closing parentheses on the previous line. Now that I see that again, that's what it is. So if it flags a particular line, doesn't mean that the error is on that line. It could be a previous line, and that is the case here. The previous line doesn't have the second closing parentheses, which is necessary for that to be a valid statement, and it just, craps out, let's say, to use a dice rolling term, it fails, and the program's a loser at this point because we didn't have correct syntax. So that's what I call it craps out. But anyway, the point is that when you're running the program, even if it compiled properly, there might be an error, year is not defined. So there's a variable called years, but that's a completely different value than year. So, Python's not going to recognize that as the same thing. They're two unique values. Just because they're off by one character does not make Python realize that anymore. But so you have to fix that. If you're trying to access a variable called year and it doesn't exist, it's going to say year is not defined. So essentially that is the end of that first chapter. And, like I said, you could use AI. Many different things are available, including the three that I pointed out. Gemini is from Google. You have to log in, I guess, in order to use it. ChatGPT, used to require always that you log in. So I'm glad that you can just jump right in and put something in the prompt, but don't get too used to it because they're always wanting to monetize these things and have you log in so that you could eventually give them a credit card, I guess, at some point. But anyway, Copilot is from Microsoft. So this one, I was probably logged into something else that was Microsoft related. So it let me in without having to log in, perhaps. But so I would try different ones. If you want to test out code, a couple more things is if you want to go into this environment, online GDB, it gives you kind of like a baseline editor that you can select a language. You can see there's many languages. So if I want to do Python 3, And then what happened to this? It's okay. So it paused for a second there, but I just pasted in that code that does the multiplication table, and then I'm going to run it, and you can see it gives me immediately, a shell, and it's, really Linux is underlying this cloud-based, internet-based solution for just testing out simple Python programs without having to install it on your local machine. But that can also be run, let's say, on a Chromebook, for example, which is just a browsing machine. So there's other ones out there besides online GDB. You can get into tutorials point, and I'm going to leave that environment. So that's one of the disadvantages, is if you leave it without saving it, that code's gone forever. But here, if I go into Python and then I want to just do, I think they have a link to like the compiler or something, or online compiler, so you can open this, and then it gives you something very similar. So if I want to say Control A, Control V, that same code, and then I could execute that. So same thing, 5 by, whoops, I'm still in that one. So 5 by 3. So you can see that this is a solution that doesn't even require that you have a specific platform or that you go through a particular install process, that you can just do this on the fly. So that's a beautiful capability. And then the third site that I'll show you is to go to W3 Schools, and you could, it started out many years ago for this company, or this W3 Schools, as a way to learn web development, but it's since, spiraled into or expanded into many, you can see how many different things that they cover, including Python. So you basically can go here, and then, if you wanted to look at something simple, like Python variables, it'll talk about that, but you have the ability to jump into this, which I call a sandbox. So even this online GDB or the tutorials point are what we could consider a sandbox. So it's basically like a controlled environment that you can jump into and play around with. But W3 Schools gives you that, but I wouldn't trust this. Let's see, I'm going to put that whole code that was generated by ChatGPT and see if it complies. So now it's saying, so you're pushing the limit here. This little shell was not designed to be a full development environment, but maybe there's an issue with the end of file. So this is just a weird anomaly there that, whether it's going to work or not, you have to test it, but really just treat it as what it's supposed to be, which is just to learn basics of Python programming. And you can also go lastly to Python docs, where it'll give you, kind of the directly from the horse's mouth, so to speak, python.org. And of course, that's where you downloaded the program, and then it also allows you to, access a particular documentation and material therein. So thank you for watching, and I'm going to make other videos, but this is the end of this one. Thank you.